All right, welcome everyone. So let's talk about prefabs. My name is Ram. I'm a software development engineer at AWS, and I primarily work on the prefabs and some of the other game object systems within Open3D Engine. So before we begin, if you're wondering what those three images mean on the title slide there, hold on to that question and we'll cover that during the course of this presentation. So my goal for this presentation is that everybody should walk away with a clear understanding of what prefabs are, how they work, and what's next for prefabs. So disclosure upfront, we will be covering the architecture and design of prefabs in this talk, and we'll be covering some of the key concepts within prefabs. What we won't be covering is how to use prefabs in the editor. If that is something that you're interested in, there is documentation on the O3D website that you can check out. It looks something like this. It goes into great detail about how to create prefabs, how to use them in the editor, and so on. So first thing I'd like to say is sorry for the wait. As many of you might know, O3D was launched in July 2021. And so were prefabs. They were actually launched with O3D. And this talk was actually supposed to happen last year in last year's O3D Con, but because of some scheduling constraints, we couldn't make it happen. But we are here, and there are a lot of topics to cover. So I'm very excited about it. And let's go ahead and get started. I'm going to ask you to hold on to your questions till the end so that we go through all the concepts. So the first thing is, what are prefabs? To understand what prefabs are, first we'll look at what entities and components are. So if you attended some of the presentations in this conference in the last few days, or if you just played around with the editor, you understand that components are these building blocks that you can put custom logic in and let define game behavior during your gameplay. And entities are basically containers that can hold one or more components so that you can build your game logic in a nice and abstracted way without putting all of the components in one place. So these are good enough for you to start building your game logic, and you can actually build your game just with this. So if you can build your game just with this, so why do we need prefabs then? Well, what if I ask you, what if you want multiple objects or multiple entities at once in the editor? And you might say, I saw this menu option called duplicate. I'll just duplicate my entity, and then I'll search for those entities that I want. I'll select them at once and then modify them. So yes, you can do it this way. But then what if I ask you, what if they don't have the same name? So searching for them becomes difficult. Or what if you want an easier way to modify them rather than going through your scene and then finding the entities and then selecting them? Or what if you want some of your entities to not get modified while you want some of them to get modified? Or what if you really like an object that you create in the world and you really like it, and another artist or user asks, hey, can I put it in my level? And you want an easier way to create that into an asset and pass around that. So with all these questions, you can start that. You can see that there is actually a need for a concept where you can group entities easily and modify them so that you can build large and complex levels. So prefabs are essentially that concept. And a prefab is basically made up of entities and more prefabs. In this case, we are calling them nested prefabs because they're within a prefab. And the idea of prefabs has been around, and the concept exists in almost every game engine. So right now, if we stop this talk at this point, you can use it to explain what prefabs are in some of the other engines out there. So the idea exists in almost every engine and studio, but the implementation is what that differs. So if you are familiar with Lumberyard or used Lumberyard in the past, you might be thinking, wait a second, these are just slices, right? So are just prefabs slices 2.0? And the answer is no. Slices were the predecessor of prefabs, and they implemented the concept of prefabs, but there are major differences between how slices worked and how prefabs work. And these are some of the major differences between slices and prefabs. Slices used an object stream XML format. Prefabs use a nice and easy to read JSON format that also can be easily merged when there are conflicts. Slices, when you propagate changes in slices, you needed to require them to save to disk and then read them from the disk again, which required a lot of input-output operations, and it was resource intensive, whereas prefabs does everything in memory so that you don't need to do this round trip to file and then read it from there again. And with slices, the topmost entity became the container, whereas in prefabs, every prefab comes with a new container entity under which everything else is put, which is super helpful because you can add custom logic on top of that container entity and not let it belong to some of the children entities out there. And with slices, the default change became an override, whereas with prefabs, the default edit becomes a prefab template edit. So this is how it is currently. With the introduction of some of the features that I'll be covering later, that behavior may change in the future. Yeah, so these are some of the major differences between the two systems. So what do prefab files look like? So we said that prefabs use the JSON format. So every prefab will have a container entity key, entities key, and an instances key. And yeah, we said that a prefab is basically made up of entities and more nested prefabs. One addition we added is we also put in a container entity there. So we have covered what prefabs are. So next, let's look at how they work. So these are some of the major milestones for prefabs since the idea has been around, and we'll be covering these milestones to describe how prefabs work. So I said that we'll come back to these images again. The first thing we wanted to do is prototype the idea of prefabs in JSON and see whether that's a viable idea or not. So the very first example that came to my mind was our mind was the wheel, axle, and car analogy. So the idea is that there will be a single wheel and wheel prefab, and an axle would have two wheel prefabs, and a car would have two axle prefabs. So we have these three layers of nesting going on here, which gives us a good example to see some of the key features of prefabs like propagation or overrides, and see how they work in JSON. So this is actually the very first thing that I did once I joined Open3D Engine. So I just created a bunch of folders, wrote a bunch of Python scripts to verify that this is something that can work. So once we gained confidence that this could work, we went ahead and wrote up the design and then started implementing the core APIs for prefabs. So these are some of the core concepts within prefabs that we'll be looking at today. So the first thing that we'll be looking at is prefab templates and how they are loaded and saved. So a template is basically an in-memory object that is created when a prefab file is loaded. So we saw that a prefab file is a bunch of JSON text, and we load it into the editor. We create something called a prefab template object. Now, the loading process looks something like this. So we start with a prefab file, and then we do something called prefab sanitization, which means that we add in the default values for types. So the JSON serializer by default doesn't store defaults, and that is to make the files clean and compact. But prefabs expect defaults for patching. So during the sanitization process, we add in those defaults, and you can see that the file doesn't have the integer actually stored on the data because the value is 0 and it is a default, whereas in the template, the default will be loaded so that it can be used later if needed for overrides or patching. So this is how loading looks like. Similarly, when saving a template into a file, we strip out the defaults so that it's nice and compact again. So that's what loading and saving looks like. In addition to adding the defaults, something else we do during the loading process is we unfold the nested instances. So a nested prefab may or may not have patches applied on top of it. So during the loading process, what we do is apply these patches onto the prefab DOM or JSON, and then store the result of that under the target template, which is the card template. Similarly, when we save the file, we don't want the templates or prefab files to look huge on disk. So we again condense the nested template into something nice and compact, which is the source to the prefab the source path to the prefab file, and the patches to be applied on top of the prefab file. So that's what loading and saving looks like. Next, we'll be looking at prefab instances. A prefab instance, as the name indicates, is actually an instance of a template that you can put into the scene. So we saw that a prefab file gets loaded into a prefab template, and then you can use this template to create multiple prefab instances. So these are some of the major differences between a prefab template and a prefab instance. So a template has a one-to-one relationship with a prefab file, whereas an instance has one-to-many relationship with a prefab template. And if you're familiar with the model view controller design pattern, you can almost think of the template as the model that represents the data, and the instance as the view of the model. And in the editor, a template is an in-memory object, so you cannot see the template when you open the editor, but instances are the things that you can see and you can create, you can destroy. Basically, you can do CRUD operations on them. So this is a scene, and we'll be looking at this later in the presentation also. But if you look at the fence object there, that is actually a prefab. And you can see prefab instance, to be more specific, and you can see that there are multiple instances of the fence prefab in the scene. So this is an instance, and you can actually do modify it in the scene. But and this is backed by a prefab template, which you cannot see. So next we'll be covering prefab links. A link is basically an object that represents connection between two prefab templates. So let's say we have a bike prefab that has two wheel prefabs inside it. So we said that during loading, we unfold the nested instances, we load in the defaults. But in addition to all of that, we'll also be creating a link object or link objects to represent the connection between the source template and the target template. So in this case, since there are two wheels within a bike prefab, there will be one link created each to represent each connection. And this is where we'll be storing the patches on the nested prefabs also, which is something really important for us to implement or implement features like overrides, which we'll be covering in the later part of the presentation. So that's links for you. And next we'll be looking at prefab propagation. So propagation is one of the major concepts of any prefab system, and the idea is simple. You modify a single instance, and you want that change to be replicated to all the other instances out there. So that's what propagation does. And before we go into the details of how propagation is implemented with prefabs in O3DE, let's take a look at a small video that shows propagation in action. So we want to find that fence prefab that we talked about earlier. So we'll search for that, and then we'll find it in the viewport. And then we found it, which has a default gray color. So next we'll open the prefab for editing, and we want to change the color to be something more interesting. So we'll pick a different color, and then we'll hit OK, and then immediately all the other instances will get the same color too. So if you look at some of the other fences in the world, you can see that the propagation is spontaneous, and with a single click, you modified all of these other objects in the world. So that's propagation in action. Next, we'll look at some of the fundamentals of propagation, or how it is implemented behind the screens. So the first thing we'll cover is patch generation. And to understand patch generation, we need to talk about serialization and deserialization. Serialization is this concept of taking your object, your C++ object in this case, and then converting into a DOM format, which in our case will be represented in JSON. And deserialization is the opposite way. You start with the DOM, and then you load it into the object of your choice. So a serialization looks like this. Let's say you have an object that has an integer, a string, and an array, an object. When that is serialized, the DOM looks something like this, or could look something like this. And deserialization, again, it's the opposite. You start with a DOM, and then you go into the object. So to generate patches, generating patches is the first step that we do for propagation. And this is an area where we have done a lot of optimizations since we started generating patches. So the very first thing we did was we serialized the entire instance to generate a before state of the DOM, and then you modify the instance, and then you serialize the instance again after you made the change to generate an after state of the DOM. And when you comparing these two DOMs, you can generate a patch. So this is like the brute force way of generating a patch. So this is fail proof, and this will work. But the problem with that is, what if a prefab has a really large number of entities, let's say 1,000 entities, and you modified only the 1,000th entity here? So in order to generate the patch that represents the change on this 1,000th entity, you will be serializing all of the other entities in the prefab too, which is obviously not cheap and expensive. So one thing that we realized is we don't need to serialize the entire prefab instance. We know the entities that the user is selecting and modifying, so we can just try to serialize those particular entities so that we bring the cost from O of n to O of 1, and we serialize only those entities that we are actually interested in and generate the patch. So this gave us nice gains in terms of times for generating patches. And then we realized one more thing after we made this change, which is we actually don't need to serialize to get the before state of the DOM as well, because we said that the template is the model and the instance is the view, and the model and the view are supposed to be in sync. So that means you can actually get the before state of the DOM from the template itself. So we can avoid one more serialization just to get the DOM of what we want. So we don't need to do this, and we do get the before state of the DOM from the template. So this is great. We optimized a lot from the time we started. But if you think about some certain cases, you don't need to do anything in here at all, because let's think of a case where you simply want to delete an entity. So you know the operation you are doing, and you know the entity that you will be deleting. So that means you know that the patch is going to look something like this. So you can actually write code to generate this patch without serializing anything, which is the fastest way of generating a patch so far. So at this point you might be thinking, this is great, so why don't we generate all of our patches this way, right? Well, I kind of picked the very simple use case here of removing the entity so that the patch is very simple. But in cases of additions or replacing values on an object, you need to also provide the value of the patch. What is the value that you need to add? What is the value that you need to replace? And the prefab system cannot know about how the serialized data of every component out there looks like. But this is something that the document property editor can help a lot with in the future. So this is an approved RFC under SIG content, and the work is already in progress. And with this, when this is integrated with prefabs, we are looking at a potential future where we can simply ingest the patch that the DPE provides and massage it in a format if needed, so that the prefab system understands it and use the same patch to represent the change without generating the patch ourselves, which will be even faster. So this is an area that I'm really excited about and looking forward to in the next few months. So that's patch generation for you, where we optimized a lot since the starting. Next, we'll be looking at something called template to template propagation. So let's say again we have a level like this, and it has 2 bike prefabs in it, and each bike prefab has 2 wheel prefabs in it. So template to template propagation looks something like this. So the idea is that you generated a patch and then you modified the DOM of the prefab. But you know that there are 2 wheel nested prefabs within the bike prefab. So the idea is whenever the wheel is updated, you look at the links that we created earlier to see whether there are connections outgoing from the wheel. And then you update the wheels within all of those connections, in this case the bike, and then the bike template gets updated in memory. And then the level again has 2 bikes inside it, so the level template again gets updated in memory. So all of this is in template space, so we did not even come to instances yet. So what we are trying to do here is update the template or a prefab template in memory and update all the dependent templates too. So that's template to template propagation. And after this is done, we do template to instance propagation, wherein we queue up all the instances that we want to propagate the changes to. In this case, since I want to modify a wheel object, those will be the 4 wheel instances. And I put them in a queue, and after template propagation finishes, I deserialize each of these prefab instances with the DOM that I updated the templates in. So with this, this is the final step that actually modifies the instance. In the earlier example, we saw that all of the fences turning the turquoise color. So this is the actual step that results in that action. So that's template to instance propagation. And after we implemented the core APIs, we next moved on to implementing the editor workflows. Again, because of time constraints, I won't be able to cover all of this in this talk, but you can find the documentation that shows how these operations look like in the editor, and we will be adding documentation soon to explain what is going on underneath when each of these operations take place in the editor and what the calls to the prefab system look like. So you can expect that documentation also in the future in the O3D website. So we implemented the editor workflows, and then we went through a stabilization phase because we were rushing to get the workflows in for the launch of O3D. So we spent quite a lot of time optimizing our systems. We optimized the time it required to do propagation, and then we improved the editor workflows, did a lot of bug fixes, and then with the help of editor team, we also added something called the prefab edit mode, which you already saw in the previous video, where the current prefab you're editing turns blue in the outliner. So that was a great addition. And then we added automated tests around all of these workflows, and not just added the tests, but in fact, we also converted all of the other tests using slices to use prefabs by default in the automated testing project. So we went through all of these optimization and stabilization phases. And the next big thing that we did for prefabs is selective deserialization. So we already saw deserialization before, which is we start with a DOM or a JSON, and then we load it into the objects. But the JSON deserializer by default doesn't take smart reloading decisions. And by smart reloading, it takes in whatever values are present in the DOM and tries to load them into the object to the best of its ability. But if that value is already present on that object, it doesn't delete it by default. So the systems that are built on top of this deserializers need to implement those smart decisions themselves. So one option we can take is go with the brute force approach of clearing everything within that object and loading from the DOM fresh. Again, this is a fail-proof way, and it'll work. In our case, when we want to load the template DOM into the prefab instances object, we can do something like this. We clear all of those wheel instances, and then we load them from the DOM. And this works. But we need to understand that each of these wheels instances are again made up of a container entities, and nested prefabs, which means we need to destroy all of them and then recreate them again from the DOM. And let's say you have 10 entities in your prefab, you can sure destroy and recreate. What if you have 100 entities or 1,000 entities in your prefab? Destroying all of them and recreating them obviously is expensive, and it is even worse with nested prefabs, because a nested prefab can have more nested prefabs under it, and it grows exponentially. So obviously we cannot simply destroy and recreate entities because it is very expensive. And not just the scale factor here. When you destroy and recreate entities, a lot of other systems are actually listening to these events, and they might be implementing custom logic on top of these events. So that's a lot of cost that you need to pay for as well for each recreation or each reloading. So what selective deserialization does is takes into the fact that for every change you make in the editor, it goes through this loop. So it generates the patch, it updates the template, and then it updates the instances. So the fact that we are building changes iteratively is something that the selective deserialization takes into account, and writes a smart logic and which we'll be covering here, which is, so we have the template DOM, and then we want to load that into the instance object. But instead of destroying and recreating everything, we use the DOM and then compare it against the previous DOM that was used for reloading that instance, so that we generate a set of patches to represent what actually changed. And once we generate those patches, we actually identify which entities are the things that got modified during the course of this operation. And in the previous example, we said that we only want to modify one entity among 1,000 entities. So the patches identify that, oh, okay, there's actually only one patch that touches this 1,000th entity. So, and then reload the instance with that data. So instead of reloading everything within the prefab, now we are reloading only the things that are actually getting modified. And as you can guess, this is a big optimization and the wins are huge. Oh, and the final thing that we do is update the template DOM to be the cache DOM again, so that it can be used for the next change that will come in. And we wrote some benchmarks for this, and we noticed that there's a 3 to 10x improvements in deserialization benchmarks with this change, which is huge. And we also did some wall clock numbers to compare how fast editor operations are with and without this change. And in cases where the prefabs or the levels are really big, we noticed that times to do operations on those large prefabs came down from almost a minute to just a few seconds, which is also great. And we did some more optimizations since June when this feature was launched. So the numbers that you're looking on the screen there are not the latest ones, in my expectation, are even faster. And this is actually available in the 22.10 release that we just launched a few days ago. So you can just get the latest from that release, and then if you had a previous release, you can compare and see how fast things are. So we have covered selective deserialization, and next we'll be covering overrides, which also falls into what's next for prefabs, which is really exciting. So the support for overrides existed since the launch of prefabs. So you can open a JSON file and you can modify it such that it has overrides behavior in it. In fact, you can see that if you actually create a prefab and save the level, you can see that there are actually default overrides provided by the system. So the support for overrides existed since the launch, and this is an actually level that has some overrides, which is why some of the blocks are in a different color. And you can load something like this in the level and see that you can actually have overrides in the system. But the missing part there is like the visualization aspect of overrides and the authoring aspect of overrides. So we added another RFC under SIG content, which is approved, and we are starting to work on this soon. The idea is that instead of saving the patches as is, we'll put those patches and generate a DOM prefix tree under each link. So to understand whether a patch exists on a specific component or entity, you don't need to pass through the 100 or 1,000 patches that exist on that link, but instead can simply query this tree and ask whether an override or a patch exists on this particular entity, which is much faster and is needed to quickly visualize changes in systems like Outliner or Inspector. So the idea is this, and this is actually a recording of a video, and right now the change exists in a remote branch, but we'll be merging this to development soon behind a flag. So what you will be seeing here is that when a level like this is loaded, right now there is no visualization in development, but this prototype shows that there can be visualization added in the outliner using this DOM prefix tree approach. And you can also see that when things are getting modified in an override mode, you get the new overrides get added by the system, and that immediately gets picked up by the visualization, and that gets shown as well. So let's play the video. So you can see that it is overridden, and when you expand the outliner, you see a small orange icon. That means it is overridden, and you pick something that is not overridden and move it, and then that gets added as an override, and visualization gets picked immediately. And then when you undo the change, the visualization goes away because the override also goes away. So this is just a small sneak peek of the many exciting things to come with overrides. So I'm really excited about this space. And because of the time constraint, we couldn't really cover some of the other concepts within prefabs like spawnables or edit more or proc prefabs, but hopefully we can cover them in the future. And this is our team. Some of us have been around since the idea of prefabs in JSON, and wanted to give it a quick shout out to our alumni as well, who are not actively contributing to the project, but played a key role since the very beginning. So that's it, and thank you. Do we have time for questions? No? Okay, you can. Okay. Any questions? All right, you can reach out to me after this, and we can have a discussion about prefabs. So thank you.